So we looked at this problem in part 1. 1.5% of the population has this rare disease. First, a group of people who had the disease were tested and 99% tested positive. Next, a group of people who did not have the disease were tested and 2% tested positive. So based on the information given, we wrote down these 6 probability values that were given directly or indirectly in this question. The next thing we do is find the probability that a randomly tested person gets a positive test result. So what is the probability that a random person who gets this test shows positive? So here, notice that none of these 6 probabilities will answer our question directly. So we have to break this down. We have to think about what it means for a person to test positive. It is possible that the person has the disease and tests positive, or it is possible that the person does not have the disease and tests positive. So there are 2 possibilities here. That's why we have the word or separating the 2 possibilities. So probability of disease and positive, no disease and positive. So that's 2 ways in which someone can test positive. Next we have probability. Remember that the OR goes with the addition rule. So we have probability of the first event plus the probability of the second event, since they are disjoint events. We just add the 2 probabilities only because the 2 events are disjoint and there is no overlap. So we have probability of D and positive, probability of no disease and positive. Next, we have to break down the disease and positive, probability of disease and positive, using the multiplication rule of dependent events. Note that D and positive are not independent. Because showing positive does depend on whether you have the disease or not. So the probability that you'll show positive is higher, obviously, if you have the disease. So there is, the 2 events are not independent, in which case we have to use the multiplication rule for events that are not independent. So probability of disease, so it's a multiplication rule because of the word and. Probability of positive, we would stop here if the 2 events were independent, but since they are not independent, we go knowing that, probability of positive, knowing that someone has the disease. We do the same thing here, and goes with the multiplication rule. So probability of ND times the probability of positive. Now we would stop there if the 2 events were independent, but since the 2 events are not independent, we go knowing that the person does not have the disease. Now all we do is plug in the numbers. So probability of disease 0.015 times probability of positive given disease is 0.99 plus probability of no disease is 0.985 times probability of positive given no disease, which is 0.02. So this is equal to 0.03455, which is approximately 3.5% when we convert the decimal to a percent by shifting 2 places to the right. And of course, that would give us 3.455. And then rounded it to the first decimal place, and that's how I got approximately 3.5%. Now, notice that the probability that someone has the disease is about 1.5%. If the test was administered to a random person, the probability that they will show positive is 3.5%, which is slightly higher than the occurrence of the disease, which is 1.5%, because of the false positives. So it should be kind of low.